I just got done looking over your reflections from Thursday, the 12th of January, and I wanted to share a couple thoughts with you as we did this. Now, this is going to be kind of crude. It'll probably be my worst video ever, which is hard for you to imagine if you've ever seen my Chem 1 pre-lab videos, but we'll go for it anyway. It's a little bit crude because I'm sitting here at the poolside and Quality Inn in Baton Rouge, Louisiana right now. This is the best I could do a cell phone video. What I want to look at was on the particular problem we had in the middle of it. We had 3 charges, and we had a place we want to know the field at. What we want to do is just draw a vector that represents that field at that point. Many of you are drawing vectors here and here and here and all over the place. If I want to know the field at this point, then the only vectors I'm going to draw are going to occur at this point. If I want to know the field at a point, I have to know what the field vectors look like at that point. So when I think about it in this problem, then here's a 5 microcoulomb charge here, and its effect over here at this point, this is where my test charge will be. My positive test charge would be a vector that looks something like that. They repel each other. They go away from each other. Likewise, if I do the 5 microcoulomb up here, it's going to repel. It looks something like that. And if I come across to this one over here, he's at like that 45-degree angle. He's a little bit shorter because he's further away. He's across that diagonal of that square. So you get this, and so you had this for a picture, and that's a fine picture, except it doesn't answer the question. The question is, what does the field look like at that point? These are the 3 vectors whose resultant will give me the field. And so the way I do that, crudely, the qualitative way of doing this is to go in and say, well, if I have 3 vectors that look like this, I have one like that, I have one like this, and I have one like that. Okay, those are really bad. Have those 3 vectors. I want to add these guys up. Then what I'm going to do is take and just pick out one of them. So I'm going to add them all together, and I'll take one of the vectors and I'll just say draw that one like that. So this one is perfectly that one. Okay. Then I can pick either of the other 2. It doesn't matter which one. Pick any of the other 2, and just take and move it over there so that its tail is on the tip of this vector. Do you remember that from Physics 1? So I take this diagonal one, let's say, put his tip right here, and just slide him over. It looks like that, 45-degree angle. There he is. And then I have to add this one in, so I take his tail and put it on the tip of this vector like this. And now if I draw a vector from this point to this point, that is my resultant vector. So my vector at this point here is just going to be, in the end, my answer is just going to look like this. It's just going to be one vector pointing like that. He won't be the length of this one, he won't be the length of that one, he won't be the length of that one. He's the sum of all 3 of those. But I just thought I'd share that with you, and when you get this back on Tuesday, some of you will find this is actually drawn on the back of yours because it took me about 3 tries to get this done. Bye.